Okay, so we are solving 1079 letter tile possibilities. You have n tiles where each tile has one letter printed on it. Return the number of possible non-empty subsequences of letters you can make using the letters printed on those tiles. So if you look at the constraints, you can maybe get a hint that this should be some sort of recursive or a backtracking based approach. And if you are familiar with permutations and combinations, there might be some kind of trick to it as well. But that's, I think, probably too complicated. And given the constraints, we can solve it with the recursive approach. So what you want to do here is, obviously, there can be duplicates in the you know letters. So you can make the count of all the letters, and then for each letter, like you iterate through, uh, let's say you have an array of 26 letters, right? So you iterate through each letter, and if the count of that letter is greater than 0, you just add uh, add it to your current string, and then recur on the next index. So technically, you don't really need to append it to the current string. You can just add one to the result, final result variable, and that would be good enough as well, because uh, we only are concerned with the total number of possible sequences, and for that you don't really need to make a count of the actual sequences itself. So let's start running. Uh, so let's define n as the total number of tiles, and we can create a list called count of length 26 for each character. And for ch and tiles, we can just append the count. So this would be count of word of ch minus word of a, capital A, as all the letters are uppercase English characters, and we can add one to that count. So for the main recursion function, we can just define a function called recur, which will take the index. If index is equal to n, we can just return. We don't really need to have a return value for this function. We can define a result variable and make it non-local in this function, and in the end just return that result variable after you call recur on the 0th index. So going back to the function, you want to iterate over all the 26 characters. So for I in range, so let's say index idx in range 26. For each index, if the count of that index is greater than 0, we we basically uh, do two things. So first we decrement its count, and then we append 1 to the result. So result plus equal to 1. This means you have found a sequence that was not visited before. So in the first example, you found A, and then you decrement its count of, so this is going to be character, uh, count of, oh yeah, so you don't really need character here. You can just write, sorry, count of index minus equal to 1. Then we recur on the next index. Then we again increment the count, and so this should be good enough. In the end, we can just return, and let's give it a run. Again, seems good enough. Submit it. There you go. I think this should be exponential. Yeah. So 26 to the power n. All right. See you tomorrow.